Okay, welcome back to Swell Academy. Today we're talking about angle bisector theorem and some examples. Now, what I'd like to do is just quickly talk about an angle. And if I were to draw, so basically showing how I'm going to draw this bisector in a sense will help you give some of the key points about a bisector. So what I'll do is I'll put a point, let's say, not drawn to scale, but 6 inches or 6 units, we'll say, from the vertex. And then from that congruent point from the vertex, I'm going to draw a perpendicular bisector to each side of the angle, the sides of the angle being this ray and this ray here. Now this intersection, of course it's not entirely accurate because I'm drawing it freehand. This intersection here is potentially what your angle bisector should be. And if it's drawn properly, these two lines, which form, I call it the perp bisector, or call it congruent perp, because we have from a point on this line, because we have from a point in this line two perpendicular segments of equal measure, we can say that these two angles are equal because this is an angle bisector. So it's good to see that and understand it as we go forward to some examples, such as, can you use the angle bisector given some of these diagrams? Now again, can you use it to solve for WYX, what this is? Well, if I have two congruent segments perpendicular to the sides of the angle, so I have two things, congruent segments, and I have some perpendicular, then yes, you could use this to solve for WYX, which would be 54 degrees. Now, conversely, I'll say inversely, the same thing goes for if I have two congruent angles, that must mean that this is an angle bisector, and because this is an angle bisector, these two sides, VU and US, should be congruent. So yes, I could say VU or UV in this case, the question. Yes, I could say that this angle bisector could be used to solve. Here, although I do have a right angle to say that these two are perpendicular, the thing that I'm not given is this idea of are these sides congruent? Now, they do look the same, but this could be 10 and this could be 9. And if those aren't congruent, then there's no way for me to really say whether or not this is an angle bisector. And if I can't say this is an angle bisector, I can't say that this is 63 degrees. I can't assume. They need to. What's missing here is maybe some slashes to tell me that those are congruent. Same thing with this example here. Yes, they do give me that this is an angle bisector. So that's one piece. You have three pieces. You need two, basically you need two out of the three pieces. You need an angle bisector, a perp, and or congruent segments. So in this, yes, I have an angle bisector, but I am missing whether or not this is perpendicular. So whether this is 3 or not, I am not sure. So here's a couple examples of whether or not we could use angle bisector. Now let's say they do, it is given to you that it is in fact an angle bisector, some of the things that you need to do is use that information. So I have a perp, 1. I have congruent segments, 2. So that means these two angles are in fact equal. They are in fact equal. And if I'm to solve for this, actually let's bring our letters this way. Negative 48, I'm going to subtract 10b from both sides, equals negative 6b. b is equal to 8, but they do want you to plug in and just use your letters S, T, U to find what angle they're asking about. So actually they're asking for this whole angle here. So I could simply just plug in for one of the two angles, in which I get 32, double that, and I'll get 64. Or you just times it by 2, and you also get 64. Continue on. Here, instead of giving you slashes, they're giving you a given information saying CD is congruent to CF, which is basically telling you, yes, you do have congruent segments along with our perpendicular. So that means, yes, these two angles are congruent to each other. So I can set up an equation, t plus 33 equals 19t minus 93. And you're simply just letters to one side, numbers to the other. And I get, okay, I'm doing negative t and plus 93. So I'm ending with 126 is equal to 18t. Let's divide the 126 divided by 18, and we get t is equal to 7. Just some algebra review to go on. To do each algebra for each, I'm just going to set you up with an equation from here on out. HI, again, they're doing the same thing. HI and HK is equal to 8. And since I have congruent segments and a perp, again, I have the angle bisector. So I can say U is equal to 6U minus 65. Letters to one side, numbers to the other, we would say U is equal to 13. You can figure the steps out on your own there. What is CDF? So they're looking for CDF. What's given to you is that you have two congruent segments perpendicular to the sides of the angle. We've been speaking about that throughout. So I can set up my equation and solve for, I'm sorry, that's terrible. Solve for what S is equal to, and then once I get S, since I am solving for CDF, I would plug it in to here. You should get like 9S 56 plus 88, 144, 16, and plug in here 160 minus 88. You could take it from there. Last but not least, here I like this one because you're given EFG, or EGF, I'm sorry, EGF is congruent to EGH. So these two angles are the same. They're both 49 degrees. And because now we know this is an angle bisector, and these two lines are perpendicular to that potential angle bisector, I could say EF, which is 7A minus 98, is equal to A plus 46, which is EH. And then you would just simply go letters to one side, numbers to the other, solve for A. And if they want either side, EF or EH, you just simply take what you get for A and you plug it in to either. They are the same. So hope this helps. Some good examples, some good understanding of angle bisector theorem. Remember, the more you fail, the more you succeed. So keep working hard. Thanks for stopping by.